in today's session. So we will go over the basic principles of Java. Yeah. I mean, in fact, it's not just the Java, any object-oriented programming. Okay. So there are four basic principles of the any object-oriented programming. So one is abstraction, and second one is encapsulation, inheritance, and polymorphism. Okay. So abstraction. So basically, when you want to think in object-oriented programming world, or even in general in real life, right? So when you wanted to think about anything, you will start with an abstraction layer or abstracting. Okay, for example, anything you want to try to explain to somebody, you will not go and give the full details of it at first shot, right? At first shot. Okay, so you will try to explain the high level concepts, and then you will go in detail. So when you are explaining the high level concepts, it's everything in abstract manner. For example, if you really think about in real world example, let's say you have a car. When you're trying to drive a car, for example, yeah. So you don't need to know the full details of how the car was manufactured, how the car was architectured, and things like that. Okay, and or when you're defining a contract. So basically, it's defining a contract without worrying about the implementation details of it, but you still able to use uh, you should able to use that how to drive the car, like steering the wheel, and there are four wheels by looking at the car, by looking at the vehicle. Okay, so when you're steering the wheel or pedals, basically a braking, accelerator, or when you're pressing the brake, so you don't know how the things are working inside the hood. Okay, under the hood, basically. Okay, so that's a way of thinking in the object-oriented programming world. Okay, so that's called an abstraction. So in Java world, usually they will implement in the abstractions in the two forms. One is abstract, one is the classes, which you will not have a complete details, and another one is interfaces. Yeah, at this point you don't need to worry about what is class, what is an interface, and all those things. You will come in the next sessions and the upcoming sessions. But right now you think an abstract is a concept of how you visualize the uh, how you really think about the in terms of the real world objects, basically. Okay, so same way how you think in the real world objects, so in the programming world also you have in the similar way. Okay, this is just an example, but don't worry about the coding and also. But if you know already Java a little bit of it, that's fine. So it's great. So if you look at here, it's an animal. So it's defining it's behaving a function, like a function method, right? So make sound, basically. Any animals can make a sound. So, but if you really look at it, it's an abstract method. So what does it mean here? So you don't have the details how the animal is going to make a sound. So depending on the type of animal, right? So if it is a cat, it will be a meow. If it is a dog, it is a bow bow kind of thing. Okay. So it's all depending on the what type of animal, what type of object you are going to construct. So, but at this point, this is a still in at the abstract level. So you don't know the details of it. Okay. So this is a basic of abstraction. Okay. That's very basic principle. So it's very important to try to understand what it is abstract. Okay. So it's again, so in the following sections, you see all the implementations: dog implementing animal, cat implements animal. So it makes a different sounds. And this is in a public main method. So this is to how to run the programming. Okay. So we'll come to know, we will see in the next sessions, upcoming sessions. Okay. So that's in a abstract. Okay. The next one is encapsulation. So encapsulation is basically when you create an object or when you construct something, you wanted to protect its some of its uh, attributes. When I say attributes, characteristics, right? Or you want to protect its behavior or nature of operations, things like that. Okay. Some of the methods. For example, when you design a car, when you construct a car, the car architect might want to protect some of the internals it. Okay, like for example, under the hood, maybe there may be so all the details users may not require to know who is driving the car. um, who is driving the car. For who is driving the whoever is driving the car, they might be given access to the steering, opening the door, unlock the car, and so lock the car, things like that for the owner of the car. And for a mechanic, so he might need to have an access under the hood and things like that. Okay, so depending on the nature of the attribute, depending on the nature of the user operations, so they may want to give an access to a specific parts of the car. Okay, in some cases, I mean, in very most of the cases, for example, giving an example car, right? So they might be having some attributes you never give an access to the end user. So some of the security protocols, some securities and all those things. But in this case, in the car case, you will not have a specific things. But for example, in case of bank account, for example, right here in this case, so you see the bank account. So you don't want to expose the balance explicitly. Someone can modify it directly, the value of the balance. Okay, so you may want to control that balance in the bank account via through some explicit interfaces. When I say explicit interfaces, debit and credit kind of thing. Okay, you don't want to go, so no banker will give you a account and then giving it to the customer, saying that you come in and do your own operations on your account. So you have to go through a teller. So the teller will have an access saying that you can deposit or withdraw kind of things. Okay, so either teller or through website or or ATM machine kind of thing. So those are the access, those are the interfaces. Okay, but you never get an access directly to an account where you can go and just put whatever the amount you want it. Okay, so those kind of things. So you wanted to protect the data with and data and methods, behaviors. Some like methods means behavior means, in this case, interface, right? When I say interface, bank account, like deposit, uh, withdrawals, credit, things like that, and doesn't matter whether it could be a the way it is giving the access to your bank account. Okay, so that is an encapsulation, which is basically binding a data and methods together, and the methods will operate on the specific data. Okay, so that's called a encapsulation, making it, tying it together basically. Okay. um, so, okay, so improves the security and ensures the control over data, makes code easier to maintain. Yeah, those are just a little, but in general, encapsulation basically is a binding a data and methods together. Okay, that's an encapsulation. So the next one is the inheritance. So inheritance allows one class to inherit properties and methods basically. So it's basically in general, if you really look at it, right, like in the real world example, when you are inheriting the um, assets from your parents and from grandparents. Okay, so you don't want to work or you don't want to earn the money what your parents already went through or already earned. Okay, you want to inherit some of the whether it could be assets or it could be some characteristics, uh, whatever it is, right? So from whatever you want to inherit from the parents. Okay, so things like that in general, even in the object-oriented programming world also. So if you define something at the top level, so you don't want to repeat the same thing. So you want to reuse some of the attributes or some of the behaviors. Okay. So that's what the inheritance. You are acquiring the properties, you are acquiring the behavior, you are acquiring the attributes from its parent. Okay. So the parent is basically in the hierarchical structure. So the super one is basically a parent. Okay. So that's what inheritance is the most important word, important concept. So you'll see all those things. But here there is example, right? So animal, for example, animal eats basically, yeah. So it's an at the abstract level. So animal can eat food, for example. Animal is at the at the a generic term, right? I say a generic term. It's not a specific concrete um, animal. Okay, so it's a concrete object. Okay, so for dog extends animal, cat can extend animal, and anything, camel can extend animal, things like that, and each one will each one will do its own things, specific things. Okay, but some of the things, like for example, eat and bark, if you see here, animal eats and animal barks. Okay, so all animals can eat the food, but here it's not, we are not saying specific kind of food, but at least when you say generic implementation, every animal eats some food. Okay, so that's the kind of implementation here. But when it comes to the barking, say every animal each animal barks in a different way. Okay, so there's a specific implementation. But here, so the id is the operation, the method or attribute. Okay, is inherited from the super class, which is animal. Okay, from its parent. Okay, things like that. Okay. So the next one is polymorphism. So polymorphism is a very, very most important thing. So you have to be you have to be very important. It's very important to understand. So polymorphism is many forms. Okay, many forms means poly means many, right? So one thing, even if you look at in our mathematics, if you know, so if I give a problem, that problem can be solved in many different ways, but achieving the same result. Okay. Uh, So like that. So polymorphism also, if you want to do if you want to perform one action or if you want to do something, so you can do it multiple ways actually. So that's called a polymorphism. Okay. So this is can be achieved in two different ways, technically. So by overriding or through interfaces. So we will see how the interfaces will be used in polymorphism. For example, in our bank account example, right? So when you're trying to deposit, so you wanted to do the deposit, okay, into your account. So there are different ways you can deposit, right? Either you're using ATM machine, or you go to the banker and teller, or you can use a mobile application, or you can go there, or you can do the internet browser. Okay. So that means there are four different ways there are four interfaces um, through which you can deposit the money basically, but it is achieving the same result. But you have the flexibility of using four different ways. That means the deposit functionality is being implemented in four different ways by using a interface is called nothing but a deposit, but the implementation is different. The deposit interface is implementation is completely different for the convenient to the user. So so in similar way in the software world, when you're trying to implement any functionality, so let's say if you want to achieve something, for example, writing into a file, for example, if you want to write into a file, so there are so different ways you can implement that method, okay, that interface. Okay, so we will see in those real world examples, but here in this case, so it is a different one of the way of is using the polymorphism. So here in this case, class called animal, so make sound. So this is another form of uh, having the same interface, same functionality, but for each specific animal it is having its own implementation. Okay, this is called a runtime of polymorphism. Okay, so try to remember these concepts, very, very important. Try to get into your mind. Abstraction, encapsulation, inheritance, polymorphism. Abstraction is basically hiding the complexities. You don't know the details basically. You will just define this is what it is going to do, this is what it is going to be, how it is going to be, not how, but this is what it is going to be, needs to be done. So you will define the interface, you will define the interface methods. Okay, and the encapsulation is basically hiding the properties, like protecting the properties or binding together that the data plus its operations. Okay, and the inheritance is basically you want to reuse the functionality, you wanted to inherit the some of the parent attributes or parent functionality, parent methods. So you don't want to reinvent the wheel kind of thing. Okay, but if you want to do it you are in the subclasses or in the child classes or in your real world. For example, if you want to earn more money, of course you can earn more money. So things like that. So you will have your own functionality, your own behavior, and but you wanted to most of the times you wanted to acquire from your parents, okay, or parent classes. So you don't want to reinvent the wheel, that kind of inheritance. Polymorphism is basically, as I said, so one name, many forms, one interfaces, one functionality can be done in different ways. It's nothing but a overloading or overriding. So we will see those more examples in the upcoming classes. Okay, yeah. Try to do these as an homework. Create an abstract class, maybe so try to create an abstract class called with shape. So we call area, rectangle, circle. Yeah. So try to try to finish these examples. Okay. So and if you struck anywhere, just let me know, and okay, and text me in the WhatsApp. Okay. Thank you.